More than a dozen Russian soldiers were reportedly eliminated in a single short window, while armored vehicles sent to support them were damaged or forced to pull back under constant drone pressure. FPV drones are no longer striking only exposed infantry. They are hunting entire defensive systems, from soldiers inside trenches to tanks and armored vehicles moving forward to stabilize the line. As Russian forces attempted to reinforce their positions after days of intense fighting, Ukrainian drones appeared overhead with precise timing. Infantry units were pushed out of cover, while armored vehicles advancing to provide support suddenly found themselves tracked from above. Within minutes, movement slowed, formations broke apart, and the momentum of the advance collapsed before it fully began. These attacks reveal a clear shift in how the battlefield now works. FPV drones are not acting as simple harassment tools or secondary weapons. They are operating as an active strike layer that pressures soldiers, vehicles, and command flow at the same time. When infantry cannot stay hidden and armored support cannot move safely, the entire defensive structure starts to crack. This raises a critical question for the next phase of the war. If both foot soldiers and tanks are exposed under constant drone surveillance, how many options remain for Russia to sustain pressure and hold ground in a battlefield that is now controlled from the low sky above? FPV drone strikes against Russian infantry trenches are shaping this fight from the first minutes, because the pressure is constant and it targets the places where soldiers are forced to stay. Ukrainian FPV teams are focusing on trench lines, shallow shelters, and temporary fighting positions in a contested sector of eastern Ukraine. And the pattern shows careful timing rather than random hits. Drones appear overhead in short cycles, strike, disappear, and return again, which keeps Russian infantry pinned and uncertain about when the next attack will arrive. The attacks do not aim to take ground right away, since there is no rush of infantry moving in behind them. Instead, the goal is to weaken the ability to hold ground over time, as repeated explosions damage trenches, collapse sections of cover, and force soldiers to shift positions under stress. Each movement inside the trench increases exposure, and each pause creates another chance for a drone to drop in from above. Video footage released by Ukrainian UAV units shows drones diving directly into trench corners and shallow dugouts, where blast pressure has nowhere to escape. Soldiers who remain still risk being buried or wounded, while those who try to relocate face detection almost immediately. This creates a narrow set of bad choices, where staying or moving both carry high risk, and that balance steadily drains focus and discipline. As the strikes continue, the trench line starts to lose its shape, because damaged sections force units to spread out and break visual contact with each other. Communication inside the position becomes harder, since shouting or moving along the trench increases exposure. Over time, small gaps appear, not because of a breakthrough, but because the line becomes harder to manage as a single defensive system. The frequency of these FPV attacks is a key detail, because it leaves little room for recovery. There is no long pause to repair cover, reorganize squads, or move supplies forward. Even when there is no explosion, the sound of drones overhead keeps soldiers alert and tense, which slows basic tasks and increases mistakes. Fatigue builds faster in this environment, and alertness drops at the worst moments. Footage from the area also shows how quickly a trench can turn into a trap once drones establish control. A position that might stop small arms fire offers limited protection from a precision dive attack. Dirt walls and wooden supports fail after repeated hits, and shallow roofs do not stop blast fragments. The trench still exists, but its value as a shield is reduced with every strike. This phase of the battle sets the tone for everything that follows, because it defines the fight as one of attrition rather than rapid advance. The pressure does not seek a dramatic collapse in a single moment. It aims to grind down the ability to stay in place, until holding the line becomes more dangerous than leaving it. From the opening strikes, the battlefield is shaped around wearing the defender down, not rushing past them. That logic explains why FPV drones return again and again to the same trench systems, and why the focus stays on infantry positions before anything else unfolds. The timing of these FPV strikes matters as much as their accuracy, because they hit Russian forces at the exact moment when defense is most fragile. After days of heavy fighting, Russian units are shown trying to repair trenches, rotate tired soldiers, and restore basic order along the line. FPV drones appear overhead without warning, turning routine defensive work into a sudden crisis that breaks rhythm and focus. When drones enter the airspace during reorganization, the defensive structure starts to lose coherence. Soldiers are no longer following a planned sequence of tasks. Instead, they react to immediate threats, which leads to confusion inside the trench system. Commands become harder to pass along, and small groups act on instinct rather than coordination. That loss of order spreads quickly, since every position is connected to the next by narrow routes and shared cover. The sudden arrival of UAVs forces Russian infantry to make rapid decisions with limited information. Staying inside damaged trenches carries the risk of a direct dive strike, while moving out increases visibility from above. Under this pressure, many choose to leave cover and reposition, not because it is safer, but because remaining still feels worse. That movement becomes the critical moment when defense turns into exposure. Once soldiers move across open ground, even briefly, detection becomes almost immediate. FPV drones track movement patterns rather than fixed positions, and open terrain removes the last layer of concealment. A running figure stands out against the background, especially when the drone operator is already searching for signs of displacement. The shift from static defense to movement changes the engagement from waiting to hunting. As movement increases, the defensive line begins to thin unevenly. Some positions empty faster than others, creating gaps that were not planned. These gaps do not look dramatic at first, yet they weaken the ability to hold the line as a system. Each abandoned section forces nearby units to stretch their coverage, which raises stress and increases mistakes during the next wave of pressure. The disruption does not stop at the frontline edge. Supply runs, short rotations, and medical evacuations slow down because paths that were safe minutes earlier become watch zones. Even small adjustments require timing and caution, which delays everything behind the trench. This creates a chain effect, where a single drone appearance affects not only the men in sight, but also those waiting deeper in the rear. By striking during reorganization, FPV drones turn defense into a liability rather than protection. Trenches no longer serve as stable anchors, and movement no longer offers relief. At this stage, holding ground demands constant alertness without rest, which is difficult to sustain. This moment defines the shift in the battle. Defense stops being a shield and becomes a point of exploitation. The line may still exist on the map, but its strength is already eroding from within, shaped by timing rather than sheer force. The expansion of FPV drone targets from infantry to armored support marks a clear escalation in how this attack unfolds, because it strikes the moment Russian forces try to stabilize the line. When Russian infantry begins to struggle inside damaged trenches, armored vehicles are pushed forward to restore control and provide cover. Tanks and infantry fighting vehicles move closer to the line, sometimes stopping near trench systems to support dismounted troops. This action is meant to calm the situation and give soldiers below a sense of protection, yet it also creates new targets that stand out clearly from the air. Ukrainian FPV teams adapt quickly to this shift. Instead of focusing only on soldiers in cover, drones redirect toward armored vehicles that are moving slowly or pausing to support infantry. Video footage from the sector shows FPVs descending toward tanks and armored carriers that appear stationary or constrained by terrain. The moment a vehicle slows or halts, it becomes part of the same kill zone as the trench it is trying to protect. The attacks focus on vulnerable areas that matter for function rather than destruction alone. FPVs are seen diving toward turrets, engine compartments, and side sections where armor is thinner. A hit in these zones does not always destroy the vehicle outright, yet it can disable movement, ignite stored fuel, or force the crew to abandon the platform. Even partial damage changes the tactical picture, because a stopped vehicle becomes an obstacle rather than support. As armored vehicles come under threat, their behavior shifts in ways that affect the infantry they are meant to help. Crews hesitate to stay close to the line, and short withdrawals begin to replace steady presence. Infantry below quickly notices this change. The sense of cover fades when the engine sound moves away or when smoke rises from a disabled vehicle nearby. At that point, the psychological balance tilts sharply against the defenders. Infantry pressure draws armored support forward. FPV then target that support. Once vehicles pull back or are damaged, infantry positions lose their anchor. This chain does not rely on one decisive strike. It relies on repeating the same disruption until the system supporting the trench breaks down piece by piece. The presence of FPV also limits how armored vehicles can respond. Rapid movement increases noise and exposure, while remaining still invites precision attack. Crews are forced into short bursts of action followed by withdrawal, which reduces their ability to coordinate with troops on the ground. Communication becomes brief and cautious, since every delay increases risk. Over time, this pattern weakens combined action, even without a large ground assault. What stands out in these sequences is how quickly the battlefield logic changes once armored vehicles are threatened from above. Tanks are no longer only counters to infantry fire or strongpoints against small arms. They become high-value targets that draw attention and risk the moment they appear near the front. This shifts the cost calculation for every decision, since losing or disabling a single vehicle can disrupt an entire local defense. The effect on infantry is immediate. Soldiers who relied on armored presence to hold exposed sections now face drones without that shield. Movement becomes more hesitant, and positions that might have been held longer start to empty under pressure. The trench line remains on the map, yet its ability to resist steadily declines. By extending FPV attacks to armored support, Ukraine turns reinforcement into a vulnerability. Vehicles meant to stabilize the fight instead attract precision strikes that deepen the crisis. Once support is threatened, the infantry below is left exposed, and the defensive structure begins to unravel from the top down rather than the front forward. Real-time UAV coordination is breaking the rhythm of Russian attacks, because it turns separate strikes into a single moving pressure that adapts as the fight unfolds. Ukrainian drone teams are not operating as isolated operators, since reconnaissance UAVs and FPV attack drones share live images and target cues while the engagement is still in motion. One drone watches movement along the trench line, another follows vehicles approaching from the rear, and FPV are guided toward whichever element becomes exposed first. This flow of information compresses decision time and removes the delay that defenders rely on to recover control. As Russian infantry reacts to pressure inside the trenches, FPV are directed to force movement rather than wait for it. Drones hover just long enough to signal danger, then dive once soldiers attempt to relocate. The situation pushes troops out of cover at moments that are already stressful, and those movements are immediately visible to other UAVs in the network. The result is a cycle where reaction creates exposure, and exposure invites another strike. At the same time, separate FPV are guided toward armored vehicles that try to move closer to stabilize the situation. Reconnaissance drones track these vehicles from distance, watching speed and direction, while attack drones are positioned to intercept once the vehicle slows or pauses. This division of roles allows Ukrainian teams to pressure both layers of the defense without splitting attention or resources. The key effect of this coordination is disruption rather than destruction. Infantry is pushed out of trenches before armored support can settle into position, and vehicles are threatened before they can provide steady cover. Neither element is allowed to operate at its own pace. Each move triggers a response that arrives faster than traditional command chains can manage on the ground. As these actions repeat, Russian units struggle to align their timing. Infantry hesitates to advance without armor nearby, while crews are reluctant to stay close when FPV are circling overhead. Communication under this pressure becomes more cautious and fragmented. Orders are shorter, pauses grow longer, and coordination between units relies more on instinct than planning. Even when no strike lands, the constant presence of UAVs forces commanders to assume that any visible movement has already been seen. This assumption changes behavior across the line, since caution replaces initiative. The battlefield effect is clear in how advances stall. A push that begins with infantry movement is checked by FPV. An attempt to reinforce with armor draws attention from above. Each response triggers a counter that arrives while the previous action is still unfolding. The attack does not collapse in one dramatic moment, yet it loses shape and direction step by step. What makes this coordination dangerous is its flexibility. Ukrainian drone teams do not follow a fixed script. Targets shift as the situation changes, and drones are reassigned mid-flight if a better opportunity appears. This keeps Russian forces reacting to the last threat instead of preparing for the next one. At this stage, the fight is no longer about single targets or isolated strikes. It is about attacking the connections that allow infantry and armor to function together. Once those links weaken, the defensive structure becomes unstable even if individual units remain intact. By coordinating UAVs in real time, Ukraine turns the battlefield into a moving puzzle where timing matters more than numbers. The result is a broken rhythm, where every attempt to regain control exposes another weakness, and the offensive slows under pressure from above rather than resistance from ahead. FPV firepower is reshaping the battle through direct pressure on both infantry and vehicle crews, because its effects reach beyond damage and into every decision made under fire. FPV drones used in these strikes carry explosive charges adapted from anti-tank grenades or mortar rounds, and this design allows small platforms to threaten much larger systems. A single hit does not need to destroy a tank outright to change the situation. Damage to tracks, engines, optics, or external equipment is often enough to stop movement and force crews to abandon their task. When a vehicle loses mobility near the front, it no longer provides support and instead becomes a problem that must be avoided or recovered under threat. For infantry on the ground, these strikes create immediate disruption. Casualties occur inside trenches, while command flow slows as runners and short movements become risky. Supply tasks that once required brief exposure now demand careful timing, since any movement can draw attention from above. The fight tightens around what can be done safely in seconds rather than minutes, and this narrows options across the position. The pressure quickly reaches vehicle crews operating nearby. Tank and armored vehicle operators learn that slowing down to support infantry increases vulnerability. A vehicle that pauses to fire or coordinate becomes easier to track, and FPV are often guided toward moments of reduced speed. As a result, crews shorten stops, limit engagement time, and avoid lingering near the line. This behavior reduces the quality of support without any order being given to pull back. Infantry units notice these changes almost immediately. When armored vehicles move less predictably or remain farther away, soldiers lose a key layer of confidence. Positions that felt manageable with nearby support now require more caution. Strategy inside the trench becomes restrained, and calling for help does not guarantee that help will arrive quickly or safely. This alters how long units are willing to remain in exposed sections. FPV pressure also affects how leaders choose between staying and moving. Remaining inside damaged trenches risks another dive strike, while relocating risks detection in open ground. Each choice carries visible danger, and repeated exposure forces leaders to simplify decisions. Short moves replace planned shifts, and tasks are broken into smaller steps to reduce exposure. This slows coordination and reduces the ability to hold complex positions. Vehicle crews face a similar problem. Repairing damage, checking systems, or waiting for instructions all require time spent stationary. Under FPV threat, these actions are delayed or avoided. Crews prioritize movement and concealment over sustained support, which changes how armor interacts with infantry during critical moments. Coordination shrinks to short, tense actions, driven by the belief that every second of delay is already exposed. These combined effects weaken the defensive structure without relying on constant explosions. Infantry becomes harder to organize, vehicles provide less stable cover, and command links operate under strain. Each element still exists, yet their interaction loses reliability. Support arrives later, movements happen in smaller bursts, and mistakes increase under pressure. Over time, positions that require steady coordination become difficult to maintain. Holding ground depends on confidence in support and clarity of command. FPV pressure undermines both by making every action feel exposed. Units remain present, but their ability to function as a unified defense declines with each cycle of attack. The latest fighting in eastern Ukraine sends a clear warning that is hard to ignore, because FPV drones have moved far beyond a supporting role and now shape the battle itself. What began with strikes on infantry inside trenches has expanded into a wider campaign that targets armored vehicles, command flow, and the links that hold a defensive system together. FPV drones pressure soldiers in cover, force movement into open ground, and then turn toward tanks and armored vehicles that move forward to restore control. Each step builds on the last, and the result is a battlefield where no layer operates safely on its own. That condition reshapes decisions minute by minute, and it changes how long positions can be held without a major ground assault taking place. The next phase of this war raises difficult questions. Will Russia adapt by adding stronger short-range air defense and new tactics? Or will drone-driven pressure continue to expand and set a new standard for modern combat? The answers are not fixed, and the battlefield is still writing them in real time. What comes next will show which side adapts faster in an era where control of the low sky matters as much as control of the ground. If this kind of clear battlefield analysis matters, like the video, share it with others, and subscribe to Military Force for more reporting on modern warfare, real battles, and the politics behind them.